Hello, I would suggest that you pause the video and try these two warm-up problems. So here are the answers. Notice that combining like terms with the first one, I added the real numbers and then I added the imaginary numbers and I kept it in standard form. In the next one, remember we want to multiply both the top and the bottom by the conjugate, which then will end up having our denominator lose all imaginary numbers. Don't forget that I squared is really -1. And then I split up the fractions, simplified, made sure that it once again was in standard form. All right, let's continue with section 1.5, which once again is all about quadratic equations. Today, we're going to focus on solving the quadratic equation by using the quadratic formula. And then we're also going to talk about the discriminants and how we can determine the number and types of solutions based off of the discriminant. So solving the quadratic equation using the quadratic formula, here are steps. We want to, if necessary, put the equation into general form. So remember, general form means all of the terms to one side and it equals 0. Then we'll identify our values for A, B, and C. And then we'll substitute them into the formula. So our formula is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So notice that the -b is being divided by 2a as well as everything that was underneath the radical. We'll simplify as much as possible. Let's take a look at our examples. So we're going to solve each equation using the quadratic formula. Notice that in the first one, it's already in our general form, which means that we can identify A, which is with the x squared term, B, which is with the x term, and then the C value is our constant. So once we've done that, we can substitute it into our formula. So once again, our quadratic formula is x equals negative, and then in parentheses, I'm going to substitute in b, plus or minus, underneath the square root, we'll have b being squared, minus 4 times a times c, and that whole entire thing is all over 2 times a. So once again, notice that every single time I did my substitution, I put parentheses around the number. So that's just going to help me not lose negative values. So if I start simplifying, notice that we'll have a -13. Underneath the radical, 13 squared is 169. Notice that if I'm subtracting, but then I have a positive times a negative, we'll end up with two negatives back to back. So that's really going to turn that into addition. 4 times 2 is 8. 8 times 7 is going to give me 56. That whole thing then is all over 4. If I continue to simplify, notice that if I add the numbers under the radical, 169 plus 56 is going to give us 225. Still all over 4. So the nice thing about this is that 225 is a perfect square. So we'll have -13 plus or minus the square root of 225 is 15. And so because we were able to get a perfect square, no more radicals means that that plus or minus symbol, we actually get to break this up. So once again, quadratic equation, we're going to have two answers. So we'll have -13 and we'll add 15 and divide by 4. And then we'll have -13, we'll subtract 15 and we'll divide by 4. So our two values for x then, when I add -13 and 15, that's going to give me 2. 2 divided by 4 simplifies down to a half. When I subtract -13 minus 15, that's going to give me -28. And -28 divided by 4 is going to give me -7. And so there are my two solutions. In the next one, notice that it is not in general form, so I need to first get all the terms over to one side. So the easiest way to do that is just to move the terms from the right over to the left. So that gives us x squared minus 2x plus 2 equals 0. And now I can start identifying A, B, and C. So A is going to be 1, B is going to be -2, C is going to be +2. So once again, my formula, x equals, we'll have negative and then b plus or minus under the square roots. we'll have b squared minus 4 times a times c. And then once again, the whole thing is being divided by 2 times a. So notice that once again, I was very careful to substitute in my numbers with parentheses, because if I look at my negative and then negative 2, that's going to turn that into a positive 2. Plus or minus under the square root, negative 2 quantities squared is 4. And notice that this time I only see one negative sign, and so we're going to be subtracting. 4 times 1 is 4, times 2 is going to get me 8. This is all over 2. Well, 4 minus 8 underneath that radical is going to give us a negative 4. And so notice that this time I have a negative number underneath the radical, which means that we're dealing with imaginary numbers. So I'm going to have an I, but the square root of 4 is also a perfect square. So this is really going to turn into 2I. And then we are able to break this apart because there is no radical. We have 2. Well, here, let's do it this way. So 2 is getting divided by 2 plus or minus, and then 2I is getting divided by 2. Okay, because we're not actually going to be able to divide or combine like terms completely because we have real and imaginary numbers. But notice that 2 divided by 2 is going to give us 1. And then over here, 2I divided by 2 is going to give us a 1I. So x equals 1 plus or minus I. So there are my two solutions. So I would suggest that you pause the video, try this checkpoint problem. All right, so once again, he had to get it into general form first. That allowed us to identify A, B, and C. We ended up, once again, getting an imaginary number. I split up the terms, and I was able to get my two solutions. All right, let's talk about the discriminant. So the quantity b squared minus 4ac, which is going to be what appeared underneath the radical sign in that quadratic formula, that in itself we call the discriminant. So there is no radical when we're talking about the discriminant. It's what was underneath the radical. So the discriminant is used to determine the number and type of solutions. So here is our three different potential discriminant answers. When we have what was underneath the radical and it's greater than 0, giving us a positive number, that means that we have two real solutions. So if I was to look at this as a graph, because remember, quadratics are like the shape of a U, our solutions, we're solving for x. It's always x equals as far as the quadratic formula is concerned. And so that's why if you take a look at this graph, there's two spots on the x-axis that the graph is going to intersect. That's why I have two real solutions. If I take what was underneath that radical, so b squared minus 4ac, and a equals 0, that tells me that I have one real solution. So once again, if you look at the picture, notice that on the x-axis, the graph is only touching at one spot on the x-axis because we only had one real solution. If I end up with that b squared minus 4ac being less than 0, meaning that we have a negative number, that means that we have no real solution. But what I would like you to then describe it as is that it's really two imaginary solutions. Okay, and so when you have an imaginary solution, when you're thinking about your graph, your x-axis and your y-axis, these are all real numbers. So that's why if you're looking at the x-axis and you see that your parabola or your quadratic is not touching it, that indicates that we have our two imaginary solutions. All right, so the directions say we're going to compute the discriminant. So that means we're going to get a number for an answer. And then we'll determine the number and type of solutions for that given equation. So when it's in our general form, once again, that means that we can identify our A, our B, and our C very easily. So in this case, A is 2, B is -7, and C is -4. So all I needed to do to determine the discriminant is do the b squared minus 4ac. So we'll have -7 quantity squared minus 4 times 2 times -4. Well, -7 quantity squared is 49. Here we're going to have a negative, and then when I multiply, I'll have a negative, and a negative times a negative is a positive. 4 times 2 is 8. 8 times 4 is 32. So add those two numbers and we get 81. So there is my first answer. So that's the number for my discriminant. And notice that it is a positive number. So that means that this whole thing was greater than 0. And so that tells us that we have 2 real solutions. So there are my 2 answers to answer this question. In the next one, once again, it is in that general form. Notice that A is 3, B is -2, and C is 4. So if I do my negative B, quantity squared, negative B, but B squared minus 4 times A times C, well, -2 quantity squared is 4. We'll only have one negative sign, so minus. 4 times 3 is 12, and 12 times 4 is going to give me 48. And when I subtract, notice that I'm going to get -44. So there's my first answer. Notice that because I have a negative number, that tells us that we have 2 imaginary solutions. And there are my 2 answers. In this third example, it once again is already in general form, so I can identify A is 5, B is 10, C is 5. So we'll do B squared minus 4 times A times C. Notice that 10 squared is 100. We'll have the negative sign here. 4 times 5 is 20. 20 times 5 is 100. 100 minus 100 is 0. And so because we were able to get an answer of 0, that tells us that we have 1 real solution. All right, so notice once again, we were not taking the square root of anything. We just had to have our original equation in general form, identify A, B, and C, and substitute it into that B squared minus 4AC. So here's your checkpoint. So pause the video, determine the number and the type of solutions. So notice this time you did have to get it into general form first, but then once you did that, we got -44, which gave us 2 imaginary solutions. So that is us solving the quadratic equations using this quadratic formula and dealing with the discriminants.